Hello everybody, this is a video presentation regarding the PN junction, Zener diode and LED diode characteristics. LED stands for light emitting diode. Zener is a special type of diode which is used in we call as switching, and PN junction diode will also have the functions related to what we call as switching. So we know the characteristics of diode, that it carry current in forward biased condition, and as it comes in reverse bias condition, it will provide you no current or open circuit. And whenever it is in the full forward bias condition, then it will flow current as we have connected a wire across that terminal. So having a look on the circuitry, or we should say the kit of this PN junction diode characteristic apparatus, this is a quite complicated, not as complicated because the wires are there, so it looks like a sort of complicated kit, and it's a heavy too. It comprises voltage regulators on the either side, 2 meters, one is voltmeter, another is ammeter, is connected for the reason to measure the current and voltage respectively. So as we all know, voltmeters are connected in parallel and ammeters are connected in series. So the reason behind providing these meters, this will give the kit the stability and ability to do the experiment without requirement of any of the other things. Talking about the precautions, you should never turn on the light. The main switch which is presented over here is never turn it on while making connections. It might cause damage to the kit as well as to the user who is using this kit. So first of all, we had made connections for PN junction forward bias. So looking at this setup, I have already connected these patch cords. Due to the reason the presentation is not going to be so boring, we will save the time for the future studies. So continuing this, I had connected first of all this 0 to 3 volt, because whichever diode had been implemented, it has the limit of 3 volts. So be aware of that. Never use the 30 volt DC input into the diode. The reason behind this, the diode might get burned and it will not be in working state after that time. So always connect this PN junction either in forward biased or in reverse biased in with this 0 to 3 volt DC. So whenever we are connecting this, look at this patch cord. This patch cord is connected to the positive terminal and it's going over here, which is going to A. You are not able to see that. So now this will give a better look. This patch cord connected from the input, which is going over this, and this patch cord which is connected to the positive terminal is connected to the A point, which is the PN junction diodes, one of the terminal of PN junction diode. This going to K. Now K is connected with a black patch cord which is going in, continuing this into the ammeter. So what we have done up to that we had connected a voltage source to that particular diode, and the output of that diode is taken to ammeter. That means the voltage provided and current will be measured. So the reason behind this connection is very clear, sounds very clear. Then this second terminal is connected to the this. That means circuit starts from here, it goes first to over here, then goes here, then goes here, then goes here, and completing the circuit comes and terminated over here. We all know the voltmeter, which is placed on the left of yours and right of mine. Right of mine is connected in parallel. So parallel connection is provided over here. This black patch cord, this long patch cord is going from that to this terminal, and this red patch cord is going from that to this terminal. So in a way we have connected this into a what we call a parallel connection. Now whenever this circuitry is made, then check for loose connections. If connections are loose, I might think that the output may vary, so it's better to check for the connections. As you checked all the connections, then we will turn on the power. As we turn on the power, this LED signifies that power is turned on. Be aware of that whenever you are using PN junction diode, we have provided these switches for 0 to 3 volts or 0 to 30 volts. If you want to use this one, then ammeter and multimeter, sorry, voltmeter and ammeter will run on the 3 volt, and when you move it to the downward, then the ammeter and multimeter will move to the 30 volt scale. And same is the case with the ammeter. It will move, right now it will move at 10 milliampere, and if you turn this switch down, then it will move for this 100 microampere. Now as we turn it on, we will certainly increase the voltage, and we know if voltage is increased, the value of current flowing to that particular diode will also going to be increased. So first of all, we will make some correction in the voltage and set to a point which is known as 0.25. We had set this, I'm not sure you are able to look at this, but my demonstration will tell you everything. We have implemented this to a particular value. Now after increasing the value to 0.5, the value of current will come says near about 2, which is in milliampere. When the voltage is 0.5 volts, the current flowing through this particular diode is is 2, which is in milliampere. Similarly, we will implement the different value of voltage, and when we turn it to 0.75, the value of current will comes regarding or near about 4. So 4 in milliampere. So for different value of voltages provided into the diode, we will get different value of current. And to end up and to add some sort of a graph type structure to the presentation, I had made a graph already. Whenever the value of voltage is increased, the value of current is increasing simultaneously. And looking at this graph, after a time, the value of voltage is going to be increased, then the current value will remains the same. This is the VI characteristics for what we call PN junction forward bias diode. Now taking the example of Zener diode, you have to follow the same instructions whatever we followed in PN junction diode. Zener diode forward and reverse bias characteristics can be easily plotted by changing the value of voltage and noting down the value of current for that particular. And for the sake of economy, we should say we have saved something by implementing the Zener diode as well as into this particular kit. So 3 experiments will be performed by our 1 kit. And as for now, I hope you enjoyed this presentation, and do good and all the best for your near future. Thank you.